Have you ever stopped and wondered how your phone knows your password is correct? Or how a video game character knows when to jump? It all feels a little bit like magic, but honestly, it all boils down to a few super simple rules. So today, we're going to pull back that curtain and take a look at the fundamental logic that powers pretty much every piece of software you've ever used.
First, we're going to start with the simplest choice a computer can possibly make, just a single yes or no. Then, we'll figure out how computers ask the right questions to get to that answer. From there, we'll see how to write a rulebook for the program, learn how to handle more complex situations, and finally, we'll see how this one simple idea is the secret behind, well, all code.
All right, let's dive right in with Section 1, a world of two choices. Before we can even think about complex stuff like AI, we have to go all the way back to the absolute basics. I mean, think about the simplest possible answer you can give to any question.
So how does a machine that really only understands electricity, on or off, actually make a choice? It seems super complicated, right? Well, you might be surprised by just how simple the answer really is.
The best way to think about it is to just picture a light switch. It can't be kinda on or a little bit off. It's either on or it's off. Period. There is absolutely no in-between. And that, right there, is the most fundamental concept a computer can understand.
In the world of programming, we have a special name for this on-off state. We call it a Boolean. It's just a fancy word for a type of data that has only two possible values, true or false. And here's the key takeaway. Every single complex decision a computer makes, no matter how advanced it seems, is built on top of this simple two-option foundation.
And here's exactly what that looks like in code. We can create something called a variable. Just think of it as a labeled box for a piece of information, and we'll call it isLightOn. Then we just assign it the value true. That's it. Now the computer knows the light is on. It's really that straightforward.
Okay, so a computer understands true and false. Great. But how does it get to that answer? I mean, it can't just know things, right? It has to have a way to figure it out.
It does this by asking a question, and more specifically, by comparing two pieces of information. The answer to that comparison is always, you guessed it, either true or false.
Now, these are the tools of the trade. These are what we use to ask those questions. They're called comparison operators. And notice the double equal sign for is equal to. That's really important because it separates it from the single equal sign, which we use to assign a value, like we just did with the light switch. These symbols are basically the computer's vocabulary for making a comparison.
Let's make this real. Imagine a theme park with a rule you have to be older than 18 to ride the big roller coaster. We can translate that rule directly into a question the computer can answer. If my age is, say, 25, the computer asks, is 25 greater than 18? The answer is true. But if my age is 14, it asks, is 14 greater than 18? And the answer is false.
So now we have our true or false answer. The computer knows if I'm old enough for the ride. But so what? What happens next? Well, it needs a set of instructions. It needs a rule book.
This is where the real magic happens. We use what's called an if-else statement. We basically tell the computer, if the answer to our question is true, then do this one specific thing. Else, which just means if the answer is false, do this other thing. It literally creates a fork in the road for our program.
And here's what that looks like in actual code. You can almost read it just like plain English, right? If my age is greater than 18, then print you are allowed. Otherwise, print you are not allowed. And just like that, the computer has its full set of instructions. It checks the condition, gets true or false, and then just follows the correct path.
Okay, so that if-else logic is pretty powerful. But let's be honest, real life is rarely that simple. Decisions often depend on way more than just one single thing. So let's see how we handle more complex rules.
What if that roller coaster has another rule? Let's say you have to be older than 18, and you also have to weigh less than 80 kilograms. Now we have two different questions we need to ask at the exact same time.
To handle this, we use logical operators. The two most important ones you need to know are and or. With and, both of your conditions have to be true for the whole thing to be true. But with or, only one of them needs to be true.
So for our roller coaster, we'd absolutely use and. If someone is 25 years old and weighs 70 kilograms, both conditions are true, so they get to ride. But if they're 25 and weigh 90 kilograms, that second condition is false, which makes the whole thing false and they can't ride.
And what if you have even more than just two paths?
Imagine movie ticket prices. There's a price for children, one for adults, and a different one for seniors. For that, we can chain conditions together using elif, which is really just short for else if. It lets us create as many branches in our decision-making tree as we need to cover all the bases.
Okay, let's zoom all the way out. We've been looking at some very small, very simple building blocks, but their impact, well, it's enormous.
And this, right here, is the most important thing to remember. Everything from the simplest little app on your phone to the most advanced artificial intelligence is built using this exact same core logic. The ability to check if something is true or false and then act on that result, that is the fundamental DNA of all software.
Seriously, think about it. When you log into a website, the code is just checking, is the password you typed in equal the correct password? In a video game, if the player's health less than 0, then show the game over screen. When you get a marketing email, there was a check somewhere that said, if this customer is interested in our product. It is literally everywhere.
So understanding this simple if this then that logic doesn't just help you understand code, it actually helps you see the invisible rules that are running our entire digital world. So now that you know the secret, what's a simple decision you make every day that you could turn into a set of logical rules for a computer?